As a level 2 certified thermographer, I'll walk you through the right techniques to ensure every image you capture is accurate, consistent, and meaningful. Here we have a metal glass filled with hot water. Now I've placed a small piece of black electrical tape on its surface. Now let's measure the temperature of this glass using the thermal camera. You can see the difference. The entire glass is at the same actual temperature, but the thermal camera shows different colors. Why? Because the surface properties are different. And that brings us to the first step in capturing the correct thermal image, setting the right parameters. The first parameter that we will discuss is emissivity. Emissivity is a measure of an object's ability to emit thermal radiation, comparing it to that of a perfect black body at the same temperature. Polished metals reflect more and emit less, while matte or painted surfaces emit more. This is why on the polished surface of the glass, the temperature reading is lower than the actual temperature, while the temperature reading on the piece of electrical tape is more accurate. To account for emissivity errors, you can adjust the emissivity value in your thermal camera by manually choosing the material's value or by selecting from the range of materials already present within the camera. Whenever possible, place a small piece of high emissivity black electrical tape on the target area and just measure the temperature on that. Transmissivity refers to how much infrared energy can pass through a material. Ordinary glass, for example, blocks almost all infrared radiation, so a thermal camera cannot see heat accurately through it. Here, as you can see, we are pointing the thermal camera at a transparent glass door. What you can see on the screen is mostly the reflection of surrounding temperatures, including our own body temperature, and not the actual temperature of the glass. That's why for correct measurements, always capture images with a clear line of sight to the target without glass or other barriers in between. However, certain materials such as germanium, zinc selenide, and special infrared polymers allow infrared energy to pass through. When using viewing ports or protective covers made from these materials, the camera can compensate by setting the transmissivity value. This is done as shown. Next, let's talk about calibration. Every thermal imager should be periodically calibrated to maintain accuracy. Calibration ensures that the temperature each pixel reads matches a known standard. During factory calibration, the manufacturer compares the camera reading against black body reference sources. But in the field, it's good practice to perform a quick verification. You can use a reference plate or a known temperature surface. For example, boiling water at 100 degrees Celsius or an ice bath at 0 degrees Celsius. If your readings consistently vary beyond plus minus 2 degrees Celsius, it's time for a professional recalibration. This is especially important for cameras used in audits, compliance reports, or warranty documentation. The Hikmicro M20W model that we are using has an auto calibration function which ensures that your camera is always calibrated according to the environment you are in. Getting these basics right ensures your images are reliable and your reports are credible. In thermography, accurate data matters more than colorful pictures. In the next episode, we'll look at how to interpret thermal images and how to use the analyzer software.